Hello and welcome everyone. Now we are going to learn about the electrical technology, and in the electrical technology world we are going to start with the very fundamental introduction of AC and DC. After that we are going to cover about the resistance, and this is the symbol of the resistance that is also known as omega. The symbol is known as omega for resistance, and then we are going to study about the capacitors, that is also called as conductors or conducers in some places. I don't know why, but they call it in general language, but the official name is capacitor. And now the next thing is inductor, and finally their network. So we are going to study about the network. They all will going to combine with the LCR circuit when we are going to study that, and we are going to start with DC and AC. So first thing first, why this topic is required in digital electronics? Well, when you are dealing with the electronics, you are dealing with the voltages, you are dealing with the current, directly or indirectly it is involved in your all the logical connections and parts. So it is important to understand at least the fundamental aspects of it. That's why I am making this section as a separate section. This will going to be a small section in which we are going to discuss about the electrical technology. One after another, we will understand the AC, DC, resistance and all that things. So with all that said, let's begin. So as you can see, I have already wrote few points so that we can discuss that quite easily, and we will not fall in any trap, or we do not have to write the most of the things and all that, because this is the general thing that we need to understand, so that when we will make our digital logic design or maybe integrated circuits in the future, we will understand that what actually happens inside of it, like in the term of voltage and current and direct and indirect and all that such things. So what is the DC? Well, DC is direct current. So DC indicates about the direct current. So what is a direct current actually means? Well, we will see that in a moment. And AC is alternate current. Okay, so let's discuss one after another all the points so that we don't miss out anything. So with the first point, let's understand the first point first. Okay, so in the DC you can imagine that there are two wires that is getting us the output, finally the output voltage that we require. So it will always going to be positive and it will always be going to negative. Okay, so this is known as direct current. Now what is in the alternate current that happens? So in the alternate current we have positive, negative, negative, positive, positive, negative, negative, positive. That's the exact meaning of alternate. So we get the output as alternated or varied, that we have also worked out so many times in our junior high schools, if you have gone through this interestingly. Okay, so now let's come up with the second point. The second point, first point we have covered. The second point is it cannot be transported to longer distances, and AC can be transported to longer distances. Well, this was the entire war of early 1900s when the Thomas Alva Edison's company, Edison Industries you can call it as, they Edison Electric actually, Edison Electric was solely working upon networking the DC only. So because of that they had to plant so many transformer and small stations everywhere so as to transport the direct current, because it's impossible to just place it at one and deliver it to anywhere you want. That happens in AC only. Like I mentioned it in this way, you can understand with my skills of the graphics. You can cover a lot of the area by AC. Okay, so we have gone through the second point, and that comes from a core part which is less efficient and more efficient. Obviously if we can transport it to longer distances, it's more efficient, and DC is less efficient in that terms. Okay, now the next point is it uses carbon brushes when we try to produce the electricity out of it, that we are going to discuss just in a moment. And in the AC we use the slip rings. Okay, just let's study this one first. So in the DC world, what we had, let's make a small kind of a generator first, and then we will discuss rest of the things. That's quite pretty much, well, I assume so. Okay, so this is north, this is south, and these are the coilings that we have, and there is our carbon brushes that we were talking about. So with these carbon brushes, we are going to get our positive and negative supply respectively. Okay, we have got it. Now, what happened in the AC case? In the AC case, we do have the slip rings. So what is known as slip rings? Let's make this one quickly. This is north, this is south. So almost when you look it at up, so it seems very much similar. Actually, it's same till this point. Just the coiling, that's the copper coiling used, and we just coil it up, and then we use two things. This is one slip ring and this is the second slip ring. So this is going to positive negative type thing, and this is going to produce negative positive type things, and this is the AC. So now to understand that, let me give you a brief clarification on that. When you are using the carbon brushes, these are the permanent magnets. So these are the magnets. Let's label these things first so that we do not fall into any wrong trap or wrong track. This is coil, this is carbon brush that I was talking about. So this is carbon brushes. Okay, similarly here is the magnet. Well, this is also the magnet, the north pole one, north pole magnet. You can call it as bar magnet. We are using the bar magnet for this case, but you can use any magnet, it works pretty much the same way. Okay, this is the copper coiling that we have made, and this is the slip ring. And now this is the most important fundamental thing that makes all the changes. We are using carbon brush here, and we are using the slip rings in the AC case. So what actually happens in the carbon brush case? Imagine that this surface, this cylindrical portion that we are seeing right here, is actually getting touched with this carbon brush when it moves to this point, and when it's above, like it's rotated, let me give its name A, B. So when it's midway, something like this, I'm trying to make it in front view so that you can see the things quite clearly. So in this way, carbon brushes are separated from that. This is the same carbon brush, we have same carbon brush. So this is carbon brush. So when it is turning means it is rotating, like this is rotating, obviously it has to rotate. So when it rotates, it is not in the contact, and when it will going to come in this kind of the place, let me try to draw it with the yellow color so that you can see the difference. And when it comes to this place, it is touching this carbon brush. Well, for the simplicity I am making this, it is touching both the carbon brush one at a time. So it is doing something like this, and this carbon brush is still separated. So what I am trying to indicate is the A part here. So we are focusing on just A part. So A part is touching right now, is not touching right now, and is touching on the right side right now. In this it is left side touched carbon brush, in this it has right sided touch of the carbon brush, and the B side came here, and in this the B side is at the rightmost portion. I guess I made a little bit of the clarification about that. You can understand it in my messy drawing. Okay, now what about the slip rings? In the slip rings, the point is very honest. Well, what I mean with that, no matter where this A point goes, like it is going here in the north direction, or it gets converted and come to this point, because of the rotation it has to rotate something like this. Let me give you a better kind of the clarification type thing so that we can see, or we can try to think that how it's working, this kind of thing. So the angle is changing, and finally the angle becomes something like this again. So this is the A portion, and here I'm trying to present the A, and here A came. A is just the name that I'm naming it, that's it, nothing much special kind of thing in that. Okay, so this is the thing. So when it rotates, it is still present in this first slip ring. If I name it first and in this one I name it second, so it's in first ring. So the positive charge is coming from the north part and this negative charge is coming from the south part in which the A is presently present. So A is at north, A is at south, and then again because of the rotation A becomes at north and then south and then north and south and north and south. Alternatively, it is south north for the B. So it is remaining in the ring itself. So no matter how this is rotating, it is still touching this ring and this ring is transferring the current, and that's why it is more efficient because we are not losing these parts. Like imagine at 180 degrees we are getting the current from the north, 180 degree we are getting the current from the south, and in between all the angles like 1 degree, 2 degree, or 181 degree, let's say, and all the kind of the possibility 270 degree, or you may also say 90 degree. So these all don't go wasted because it is always touched with the slip ring. So it is amateur, we can say amateur is always touched with the slip ring, and in the DC case it is not always touched with the carbon brushes. That's the most important fundamental difference that revolutionized entire AC and DC thing. I hope you have got a little bit of a clarification about that. I will also add a little bit of the notes part specifically for AC and DC so that you can watch the things and can learn more about this. Okay, let's come back to our last point, maybe second last point. So the fundamental equation for the DC is V is equals to IR. This is Ohm's law that we are going to discuss in a while. And Q is equal to IT, which is charge is equal to current multiplied time. And in this case, we have the voltage written as V naught sine omega t plus minus phi. Well, what is this trigonometric function doing here? That I was talking about. At the 90-degree point, the sine 90 becomes 1 and this is your DC. You can imagine it like this. But AC is working on 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, and also it is working at 90 degree. So it is covering all that thing that was missed for. That's why it is more efficient. Well, I hope mathematically you got my point. So now the last part, which is our graph part, this is V and I graph. So this is the graph for the DC. Well, you can imagine the current is going through and producing the voltage in that role, but there are the gaps. That gaps we have talked about, 1 degree, 2 degree, 3 degree, all are producing the gaps. So to fulfill that gap, we have this blue line here, and that was one of the revolutionary idea of Nikola Tesla. So Nikola Tesla sir actually discovered a way that there can be a second wave which is covering the blank part of it, and the AC was born. Well, I hope you have got this basic idea about the AC and DC, and now we are going to proceed to the next level of it, which is resistance. But obviously we will do that in the next one so that you will not feeling like messed up. You can revise this thing till that time. Take care and sayonara.